Now, a little note here, and I'm going to stress the word almost, we almost always write the positive element in a formula for a compound first and the negative element last. An example of this for hydrogen, hydrogen has a positive 1 and the chlorine has a negative 1 in hydrogen chloride or hydrochloric acid, which just turns out to be when you dissolve it in water. And that's the way it usually is. Almost always. One of the only exceptions you'll see to this rule is ammonia. In ammonia, actually the hydrogen is +1 and we put it last. The nitrogen is a -3. You'll learn about this when we get to the unit on acids and bases, and the fact is this is a base, a weak base, but if you put the hydrogen first, it looks very much like an acid. So when we get down the road to acids and bases, that'll become more clear as to why that is an exception to the rule. It'll make a lot more sense. The third rule we have has to do with group 1 metals. Now there are a few alwayses in this, and the first one is the group 1 metals. Group 1 metals are always +1. There are no exceptions. The next always has to do with the group 2 metals. They are always +2. And like we said, for these two, there are no exceptions. This is always the case. The reason I'm stressing this so much is when you're trying to figure out oxidation numbers in a compound, find something that has a rule with no exceptions. Start there. It makes things a lot easier. Examples down here, the sodium's +1. That means the chlorine has to be -1 because there's no exceptions to the group 1 metals. The calcium's a group 2 metal. It's +2. That means it requires 2 of these chlorines at -1 apiece. There's no exceptions to the group 2 metals. The second of our no exceptions section of the rules is fluorine. Fluorine's the most active element on the periodic table. It can take electrons from literally any other element. It is always -1 in compounds. The other halogens are usually -1. These guys are usuallys. Just easier to say than always is. And it's the exceptions to that. Oxygen is more electronegative than the rest of those guys. So oxygen will trump them sometimes, but don't worry about it. You'll hardly ever see that. Remember that fluorine has no exceptions. And again, this one only applies to fluorine. The other halogens aren't always -1, they're usuallys. So in this, again, the group 1 is always +1, the fluorine's always -1. That's a straightforward example where both the elements have rules with no exceptions. Hydrogen, there's two possibilities. So we start with the bromine. We know that bromine is -1. That means hydrogen in this case is +1, if that indeed is the formula for hydrogen bromide. And it is. And then you look at lithium chloride. This again being the formula. The rule that I would start with on this one is actually the group 1 metal because there are no exceptions. All right, and that means the chlorine would then be -1. Fifth rule has to do with hydrogen. Hydrogen is +1 almost all the time. The only time hydrogen isn't going to be +1 and lose its lone electron is when it forms bonds with something that wants to lose more than hydrogen does, something that's a bigger loser. And really the only two groups on the periodic table that contain elements that are bigger losers in terms of electrons than hydrogen are the group 1 and group 2 metals. You'll rarely see it with a transition metal, although it's possible. It's usually going to be with a group 1 or group 2 metal where they try to show you the exception to the rule. So here, these guys, hydrogen's usually +1 and the chlorine halogen is usually -1. Lithium in this case is the one you start with here, because now we're showing you the exception to hydrogen's rule. Lithium is a group 1 metal, so it is always going to be +1. that means that the hydrogen must be -1 if the formula is LiH, which it is. The sixth rule has to do with oxygen, and oxygen is usually -2, and when we say usually, again, this is an almost always. The rule for oxygen is -2, and there are two exceptions. So if we look at this and we say, okay, we got water, oxygen's rule is -2, there's one of them, there's two waters. In order to add up to 0, they must each be +1. Two of the positive ones plus a -2 gives you an overall charge of 0. Here, -2 for oxygen, it follows its rule, because I'm giving you two of the non-exceptions. -2 times 2 is -4. So the carbon has to add up with -4 to equal 0, meaning the one carbon must be a +4. +4 and -4 equals 0. Those are two examples where oxygen follows its rule. One of the exceptions for oxygen, we'll call it A, is when it's combined with fluorine. We said that fluorine is the only other element on the periodic table that's more electronegative, which means it has a greater desire for electrons. In this case, the oxygen is going to be a +2. It forms a compound OF2, oxygen difluoride. Since fluorine has a rule with no exceptions, we start with that. So -1 for the fluorine times 2 gives us a -2 overall on the fluorines. That means the oxygen, we must, whatever the charge on oxygen, it must add up to 0 when we combine it with the -2 from the two fluorines. So that means in this case, oxygen is +2, giving us an overall charge of 0. So one exception is when it's combined with fluorine, because fluorine is the only element on the planet more electronegative than oxygen. Exception B is when we find oxygen in something called a peroxide. Peroxides have the general formula X2O2. I have two of them below. It's almost always hydrogen or a group, any of the group 1 metals or hydrogen. So any elements in group 1. In this case, in a peroxide, oxygen has the charge -1, which means since there's two of them and there's two hydrogens, the hydrogens must be +1, which again is good for the hydrogens because that's their top choice for oxidation number. It's the first one you see. In the peroxide next to it, and this one being sodium peroxide, sodium has a rule with no exceptions. It's +1. That means the oxygen has no choice in this case but to be a -1 in order for us to get an overall charge of 0. So the other ones you'll see, Li2O2, you'll see K2O2, you'll see Rb, rubidium peroxide. Any of the group 1 elements can form peroxides, and they have the general formula X2O2, the X being hydrogen or the group 1 metal.